They are subjective questions asked in CBSE board. There are two diodes D1, D2 connected like this. So resistance of the circuit, battery voltage 10 divided by 2 ampere current. So it is 5 ohm. Now it is only possible ये 2 और ये 3 D2 का या D1 का कोई एक सर्किट में हो, दूसरा नहीं हो. It is only possible. So possibility 1. Here D1 is forward bias and D2 is reverse bias. That is open means this 3 and 2, it is 5, or possibility 2. Here D1 is reverse bias and D2 is forward bias. Even then resistance, both the cases 5 ohms. So either possibility 1 or possibility 2. It means at a time any one diode out of D1, D2, one is forward, other is reverse bias, and vice versa. In this question, full wave rectification, input output transformer, number of turns in the secondary is twice than primary. So voltage secondary must be double than primary. And there are two diodes, plus the output we are getting AC. So here, because of this diode cap up transformer, secondary voltage RMS value, it is given in the question 10 volt. Secondary double means 20 volt. Primary 10, in secondary 20. And the peak value, this is the RMS value and this is the peak value or maximum value, is say 20 root 2. And DC output here for full wave rectifier, is 2 upon pi the maximum voltage. So 2 upon pi and 20 root 2, that's solving it 3.14, 20, 1.414. So it comes here 18 volt. The answer here. In this question, output waveform across the resistance in V0 and across the diode. So here for positive half cycle, input as positive half cycle 0 to 1 volt. This diode is forward bias, so it conducts, means this current will come across the resistance. So V0 should be this output across the resistance. And for negative half cycle minus 1 volt and 0 volt, this diode will be reverse bias, so it will not conduct. It means this signal for reverse biasing across the diode, so diode output will be minus 1 volt and 0 volt. This question is given the drift current 10 microampere and the biasing current is 60 microampere is given in the question. Now in reverse biasing condition, diffusion current must be 0. Forward bias, diffusion current minus drift current, but they are in opposite directions. That is say bias current. So diffusion current minus drift current 10 microampere is 60 microampere. So diffusion current will be 10 plus 60, that is 70 microamperes. The answer of 1 and hello. In this question, C1 and C2, they are pure silicon, pure semiconductor. When it is doped with arsenic and it is aluminum pentavalent impurity atom, or sometimes it is called donor atom, it donates electrons to the crystal, whereas aluminum is acceptor trivalent impurity atoms. It accepts electrons, rather it is creating holes. So C1 behave as a N-type semiconductor because charge carriage is negative electron, and here it is a P-type semiconductor after doping because hole is the majority carrier here. So this is the first part here. The second, doping of intrinsic semiconductor necessary. The reason behind here is the conductivity of pure semiconductor is less. So it cannot be used as conductor as well as insulator because of conductivity is less. But by doping either by say pentavalent or trivalent, by doping conductivity increases to sufficiently large value conductivity increases. Now it is very useful. That is why doping is necessary, and if conductivity increases, it can be used in so many devices. Hello, in this question, this is the PI characteristics for forward biasing and reverse biasing of PN junction diode. Say question 2, the threshold voltage. Sometimes it is the knee voltage or threshold voltage above which the current increases sharply. Because the battery voltage is more than the 7.7 volt equal to the barrier voltage, then a position is roughly stopped. Even if you increase a little bit voltage, current forward biasing increases sharply. So this voltage is called knee voltage or threshold voltage. After 1.1 and 1.2 volt, this saturation level comes here. The current is not increasing much. In the reverse biasing, current is not getting. Even microampere current is not getting. But after say breakdown voltage, suddenly covalent bonds break, then availability of minority carrier increases suddenly very large. So increment in the current is also very sharp and increasing, but reverse biasing current microampere is much less than the forward biasing current in milliamperes. So we have discussed this second part. So now third part, the property due to which junction diode makes it suitable for rectification. Here the basic property of this diode here is if P region is connected to positive and N region is connected to negative, it is called the forward biasing and it conducts. Whereas for negative half cycle, that is the reverse biasing, it will not conduct. It means AC part is converting into DC part with the use of this diode. It acts only in forward biasing condition. It will not act in reverse biasing condition. So this is the necessary property here, is making it suitable for the rectification of AC voltage AC to DC. Hello, in this question, this is AC supply like this. For positive cycle, this diode D1, for positive cycle D1 diode is at forward bias. It is allowing the current conducts, whereas D2 it will not work, it is reverse biasing. But for negative half cycle, D1 diode is reverse bias and D2 will be forward bias. So at a time only D1 or D2 diode, only one diode will conduct. For the forward biasing, this diode conducts. For the reverse biasing, will not conduct. Now the second part. Here, if we see the polarity of this battery here, 5 volt, D1 diode, P region positive, N region negative, so it is in forward biasing. With battery voltage 5 volt, D1 diode is forward bias, so it conducts, whereas D2 diode is reverse bias, it will not conduct. It means this will be as open circuit. Now current in the circuit like this, current in the circuit is voltage 5 divided by diode D1 giving a 30 ohm resistance. The total resistance is 30 plus this 100 plus this 70, that is 5 divided by 200. 0.5 10 power minus 2 can be written as 25 milliampere and this is the current less than 30 milliampere at or above which it fails. Burnout. This current 25 is less than 30 milliampere, so this diode D1 is safe. And D2 diode is also safe. What is the reason? There's no current flowing here due to the reverse biasing. So both the diodes are safe. Hello, in this question, if AC source is there and we are talking about positive half cycle of AC source, what is positive means D1 and D3. For positive half cycle, D1 and D3 diodes are forward bias, so they will conduct, and D2 diode is reverse bias, will not conduct, and imposing the infinite resistance or open circuit. So this circuit is converting for positive half cycle like this, reverse bias open for positive half cycle. So this is the total resistance R2R parallel. So total resistance is resistance effective for only the power delivered. This case is 1 by 2 of V square by R. For negative half cycle, D1 and D3 are reverse bias. They will not conduct. They are behaving like open circuit, and only D2 diode forward bias will conduct. So circuit will become like this. 2R and this resistance is R. Diode supply source for negative half cycle. So here effective resistance will be 2R plus R 3R. Power delivered here is 1 by 2 of V square divided by the resistance is 2. Then one full cycle total power delivered will be equal to 1 by 2 V square upon R plus 1 by 2 square by 3R. V square by R कॉमन ले लेते हैं. Here 1 plus 1 by 3, so it is 4 by 3. It's 2 by 3 V square upon R. This is the answer here. Now in this question, dopant elements from group 13 like bismuth, antimony, arsenic and phosphorus, they replace the silicon or germanium atom and not distort the lattice of germanium or silicon pure semiconductor after completing their octet by covalent bonds, and one free electron is given by the dopant. Similarly, from dopants from group 15 like aluminum, boron and indium, they also replace the silicon and germanium atom pure semiconductor lattice and is not disturbing at all. And one more electron is needed or create a hole. One more electron is required here, create a hole in the lattice structure. So they are used in group 13 and 15, and this way both create or increase the conductivity. Conductivity increase by this, either by hole from donor atom or holes by acceptor atom from group 15 by group say 13. Now in this question, if say suppose the N type, this P type, this is the barrier voltage here, depletion with D, having say very high resistance provided by this barrier. If we connect across it a voltmeter like this, voltmeter resistance is quite high. Resistance is quite high. Even then some current is passing through the galvanometer. But here the barrier resistance is very large, of the order of say infinite. That is open circuit. In this case, no current flowing through the voltmeter. If there is no current flowing through this voltmeter, voltmeter cannot measure the barrier barrier voltage, not possible by the voltmeter. Now in this question, if the input voltage is more than 5 volt, if the input voltage is more than 5 volt, then diode will be in forward bias. So it will be in forward bias. Means this diode conducts. If it is conducting, this voltage will appear, or voltage signal graph will appear across R and not across the output. If input voltage is less than 5 volt and for negative half cycle, negative half cycle, the diode will be reverse bias. It will not conduct, and this is the output voltage as shown in figure. Output voltage will be like this as shown in figure. So this is the voltage across output, say X and Y. We are getting this sort of. Hello, in this question, it is given in the question, forward bias resistance is 25 ohms and reverse biasing is resistance infinite open circuit. It means this central diode will be open circuit, reverse bias, I3 current is 0, and this circuit will like this. Diode resistance is 25 ohms and this is 125 ohms, and this current here is say I4. Similarly, I2 is diode resistance 125 ohms, and this is say I1 current on the battery 5 volt, and here it is 25 ohm resistance. So the total resistance will be 25 plus 125, 150, and it is also 150 parallel. So 75 plus 25, so that comes here 100 ohms. Now I1 will be voltage divided by this, so it will become 0.05 ampere, and I3 is 0 and I4, I2 both are equal. They are equally divided, so will be divided by 2.05 ampere. So these are. So in this question, only for positive half cycle input voltage is there. So maximum voltage of input is 12 volt maximum, and for positive half cycle, D1 diode is reverse biases, will not conduct, act like open circuit. Only D2 diode is forward bias, it conducts. Because of this, we are redrawing the equivalent circuit like this. D2 diode, 0 resistance, D1 open. So this is the circuit here. V1 voltage across the 1 kilo ohm, V2 across the 2 kilo ohm, V3 across the 3 kilo ohm. So this is the input voltage appearing as V3. So V3 simply 12 volt, and V1 upon V2 ratio I in this current, suppose I in the circuit series current is same, so I into R1 1 kilo ohm, I 2 kilo ohm, ratio is now V1 by V2, V1 plus V2 is what? Total voltage V3, that is 12 volt. Solving this, V1 is 4 volts, V2 is 8 volts, and V3 is 12 volts. Here the answer.